Okay, in this video, let's talk about the section 8.2, the inverse trigonometric functions continued. Section 8.2, the inverse trigonometric functions. Continued. Okay, so this section has two parts, four parts. Short, it's not big. So, part one. In the last section, we learned how to evaluate sine inverse of sine of x or sine of sine inverse of x for different input of x. And for sine, cosine, tangent, sine inverse, cosine inverse, tangent inverse. And in this section, we are going to mix them. So you see here, this sine inverse and sine, they are paired. What happens if we mix them? Find sine of tangent inverse of 1/2. Okay, so it's a mixed. You have sine, you have tangent inverse. Before we do this problem, let's emphasize something. Sine inverse is between negative pi over 2 and the positive pi over 2. Okay, the output, the value is between negative pi over 2 and pi over 2. So it is in the quadrant 4 and 1. It's either in the fourth quadrant or in the first quadrant. Cosine inverse of x is between 0 and pi. So the image is the first and the second quadrant. Between 0 and pi over 2 is the first quadrant. Between pi over 2 and pi is the second quadrant. And the tangent inverse of x is between negative pi over 2 and positive pi over 2, excluding those two endpoints. It's also in quadrant 4 or 1. Okay, so this is very important. And also, first quadrant, the sine inverse corresponds to x between 0 and 1. Fourth quadrant, for this x is negative, x between negative 1 and 0. And the cosine is in the first quadrant if x is between 0 and 1. It's between 0 and 1, it's correct. And in the second quadrant, if x is between negative 1 and 0. And the tangent inverse is in the fourth quadrant if the x is less than 0. It is positive if it's in if the value is in the first quadrant, and then the x is positive. Okay, remember the tangent inverse, the input is from negative infinity to positive infinity. So you don't have the greater than stuff. It's all just less than 0 in the first quadrant, greater than 0 in the less than 0 in the fourth quadrant, greater than 0 in the first quadrant. Okay? So back to this problem. Tangent inverse of 1/2. Because its input is a positive, so it's in the first quadrant. It's in the first quadrant. And then sine of tangent inverse of 1/2. In the first quadrant, at least we know it's positive. Okay? And then let's see this. Let theta be tangent inverse of 1/2. Theta is tangent inverse of 1/2. Then tangent theta is 1/2 by the definition. Okay? And then you draw the graph. 1, 2. You draw a right triangle with the acute angle theta. The opposite is 1, adjacent is 2. So this tangent is 1/2, 1/2. Then by the Pythagorean theorem, c squared is equal to 5, so c is the square root of 5. The Pythagorean theorem gives us c, the hypotenuse, is the square root of 5. Then what we are looking for? We are looking for sine theta. Theta is tangent inverse 1/2, so we're looking for sine theta. Sine theta is opposite over hypotenuse. Because we already know that this is a positive value, so you don't put any sign. So the value will be 1 over square root of 5. So this is the answer. This is the answer, okay? 1 over square root of 5. Okay, let's see another one. The cosine of sine inverse of 1 over 3, negative 1 over 3. If we let theta be sine inverse of negative 1 over 3, this implies this theta is in the fourth quadrant. So theta is between negative pi/2 and 0. Theta is in the fourth quadrant. In the fourth quadrant, cosine theta is positive. It's still positive. In the fourth quadrant, negative fourth quadrant, positive first quadrant. Cosine, negative in the second quadrant, positive in the first quadrant. Okay? Okay, now let's see. Sine theta is the sine inverse of 1 over 3. Then sine theta is negative 1 over 3. Forget about this negative sign. It's a 1 over 3. So you draw the right triangle with this reference angle theta. 1 hypotenuse, opposite is 1, hypotenuse is 3. So this, we don't know the adjacent. So the adjacent square plus 1 square is equal to hypotenuse square. So a squared is 8. 9 minus 1 is 8. So a is square root of 8. It's 2 times square root of 2. Okay, then what is cosine? Cosine is adjacent over hypotenuse. Cosine theta is the adjacent over hypotenuse. Because it's positive, so this is the answer. Okay, so you can see from those two examples, when we try to evaluate the trig functions with inverse functions, we first determine the interval, the region which quadrant this angle is in, and then for the specific angle, we determine the sign of the corresponding trigonometric functions. It's positive or negative. If it's a positive, later you will do nothing. If it's negative, later you will put a negative sign. And then you forget about this, the sign. You just use theta equal to sine inverse. You get the sine theta is 1 over 3. And you use the reference angle to draw this right triangle. From the right triangle, you can determine the other side, either hypotenuse or the opposite of the adjacent. And once you determine it, you use the definition of trigonometric functions for the acute angles to find the value, and then you use a sign to change the value, maybe plus or minus sign. Okay, so that's always the case. Now let's see another one. Example, so we are looking for the tangent of cosine inverse of negative 1 over 3. Okay, so let theta be cosine inverse of negative 1 over 3. Then, you see, it's a negative. The input is negative, so theta is between pi over 2 and the pi. It's in the second quadrant. In the second quadrant, tangent theta is negative, so tangent theta is less than 0. Just keep this in mind. Your final answer should be negative. And then theta is cosine inverse of negative 1 over 3. Then cosine theta is negative 1 over 3. Okay? And then you consider the reference angle, cosine theta. We put a theta here, adjacent hypotenuse. You can put whatever place. I just draw it in the in this way, so whatever. Okay, so adjacent over hypotenuse is 1 over 3. Then what is the opposite? So b squared plus 1 squared is equal to 3 squared. So b squared is 8. So b is square root of 8 is 2 times square root of 2. So the opposite is b, is 2 times square root of 2. And then what is a tangent theta? Tangent theta by definition is opposite over the adjacent. So it's a b over 1. Those are just values. But remember, this is negative, so you put a negative sign. So it's negative square root of 2 over 2. Over 1, you don't need to write it. So b is a 2 times square root of 2. So it's a negative 2 times square root of 2. This is a tangent theta. Okay? So that's a example, not second. That's a second example. That is the evaluation of a mixed sine, cosine, tangent with sine inverse, cosine inverse, and tangent inverse. Let's do some more. Let's try. For example, tangent of sine inverse of negative 1 over 2. So we let theta be sine inverse of 1 over 2. Then theta is in the fourth quadrant because your input is negative. Sine inverse is in the fourth quadrant. In the fourth quadrant, the tangent of theta is negative. Tangent is positive in the first and the third quadrant. This fourth quadrant is negative. Okay, and then theta is a sine inverse of 1 over 2. So sine theta is negative 1 over 2. Then we talk about the reference angle. 1, 2. Opposite is 1. Hypotenuse is 2. Okay? Opposite is 1. Hypotenuse is 2. Then a squared plus 1 squared is equal to 2 squared. So a squared is equal to 3. A is equal to square root of 2. Square root of 3, my bad. Square root of 3. So what is a tangent theta? Tangent theta is the opposite over adjacent. Opposite. Tangent theta. Because it's negative, so you put a negative opposite over adjacent. So it's negative square root of 3 over 2. Square root of 3 over 3. Square root of 3 over 3. See? So this negative tangent theta will give you the negative sign. Otherwise, you read it from the opposite over adjacent, you will have positive number. Okay, so we just put the negative sign to make it a negative. Okay, so this is the example, additional example. Do your exercise and try to understand those steps. They are not difficult, but it's just be familiar with the quadrant. Negative is in the second quadrant. This negative is in the fourth quadrant. Okay. Okay, now let's see. We're going to define the inverse secant, inverse cosecant, and inverse cotangent. Okay, let's try to memorize those stuffs. For example, remember what is a cosine. How do we define the inverse cosine? We pick up the graph over 0 to pi. Okay, over 0 to pi. And we also pick up 0 to pi, this region, and we try to sketch the graph of a secant of x. You see, secant of x will be like this. And the secant of x is undefined at pi over 2. Okay, so this is a one-to-one function. So we can define the inverse secant. So the inverse secant y is secant inverse of x if and only if x is secant of y. Okay, so y is in the y is an angle, so y is between 0 and pi, and the y cannot be pi over 2. Okay, so this is our input of y. And x is a value, so x is either greater than or equal to 1, or x is less than or equal to -1. This is a 1, this is -1. So the domain of a secant inverse of x is either greater than or equal to 1 or less than or equal to -1. The range for our choice is like this. We choose pi, y is between 0 and pi, and without pi half. This is one of a common selection, but it's not the unique selection. Some textbooks use different selection to define the secant inverse. But for us, we just choose this because this definition corresponds to the selection of a cosine and its inverse cosine. Okay? So this is a secant inverse. Let's see cosecant inverse. Cosecant inverse. Let's talk about the sine first. This is sine. Then what is the graph of a cosecant? It's a graph of cosecant. The red curves are the graphs of cosecant over the negative half 2 and positive half 2. Because for the inverse sine, we choose negative half 2 to positive half 2. So here, for the inverse of a cosecant, we also choose this domain. So definition. Y is cosecant inverse of x if and only if x is cosecant of y. So y is input. Y is between negative pi over 2 and positive pi over 2. And y cannot be 0. It's a vertical asymptote. And x is the image. You see, x is either greater than or equal to 1, or x is less than or equal to -1. So here, this is a domain. This is a range. Same thing. Here is a, let me do it. This is a domain. Sorry, my bad. My bad. This is range. Y, when you see y, it's a range. This is domain. Okay? So we try to get the domain range based on the range domain for the secant of x. Y here belongs to the domain, so the y is between 0 and pi, so that's why y is here. X is in the range part, so it's greater than 1, less than -1, so it becomes a domain. Okay, so this is a secant inverse and a cosecant inverse. Again, secant and cosecant, especially the range depends on the selection of the branches. Because for the sine and the sine inverse, we choose this branch. So for the cosecant, we also choose this branch. For the cotangent, for the cotangent, it has a natural branch because it's like the tangent. Tangent has several vertical strips, vertical curves. Cotangent also has those vertical curves. They are piece by piece. They are not intersected. They are very complete. So we're going to choose this piece. We're going to just choose this piece for the y equal to cotangent of x. It's between 0 and pi. And we use this piece to define its corresponding cotangent inverse. So y is cotangent inverse of x if and only if x is cotangent of y. See, okay? So cotangent of y is between 0 and pi. And this time, 0 and pi, x equal to 0, x equal to pi are both vertical asymptotes, so you cannot reach 0, not reach pi. And the x here is a range, so x is greater than negative infinity, less than positive infinity. So y is a range, x is a domain. This is the cotangent inverse. And those three definitions are on page 618. You can check those and get the idea. Okay, so let's see something. For example, let's use secant. Secant inverse of x. What is, how do we understand it? Secant inverse of x, let's assume secant inverse of x is theta. Then it means x is secant of theta. Okay, you just pass to the secant function. The secant is 1 over cosine. So x is 1 over cosine of theta. X 1 over cosine theta. Then what we get? We switch x and theta, so we get cosine theta is 1 over x. Cosine theta is 1 over x. Okay, so check here. Theta is in the range of secant inverse. So theta is between 0 and pi. Once this angle is between 0 and pi, you can apply the inverse. So theta is cosine inverse of 1 over x. Okay, so here we use a condition. Theta is between 0 and pi. Theta is not equal to pi half. With this condition, you can directly apply the inverse. If you have different the domain, you cannot apply it directly. Okay, so what we have? We have here we have secant inverse of x is always cosine 1 over x. Always, for whatever input you have. Okay? For whatever input you have, secant inverse of x is always cosine 1 over x. And similarly, cosecant inverse of x, because you see secant is 1 over cosine, cosecant is 1 over sine, so it's a sine inverse of 1 over x. And cotangent inverse of x is equal to tangent inverse of 1 over x. So this is the relation. And this is actually the reason sometimes we don't use cosecant inverse, secant inverse, and cotangent inverse a lot, because they are actually cosine inverse, sine inverse, and tangent inverse, just with a reciprocal. No special stuff. Okay? So for example, if we want to find what is a cosecant inverse of 2, cosecant inverse of 2, by this property, it's just a sine inverse of 1/2. Sine inverse of 1/2, we know it's a pi over 6. If you don't know how to find it, read that table. We have that evaluation table. This is a pi over 6. Okay? And there are some examples to use a calculator to evaluate the secant inverse of x, cosecant inverse of x, and the cotangent inverse of x. From those stuffs, you will see that they always transform. Okay, example 5 on page 619. Example 5 on page 619, they always write secant inverse, for example. They always transform secant inverse to the cosine inverse and the cosecant inverse to the sine inverse and the cotangent inverse as a cosine inverse, whatever. But so it just means we actually we're interested in the cosine inverse, sine inverse. These three inverse trig functions are less important than the first three, okay? Because of this condition. They are less important than the first three. All right? So you have to know the definition, and for the practice purpose, possibly they only study the cosine inverse, sine inverse, and the tangent inverse. And because in the exam you cannot use calculator, so I just skip the process. Let me just do one problem. Let you to see how they transform it. For example, they want to compute. This is example 5, part C. Cotangent inverse of 1/2. Of course, cotangent inverse of 1/2 is a tangent inverse of 2, but still, it's not that straightforward for many purposes. Let's transform cotangent inverse of 1/2 to the sine inverse or cosine inverse. So for example, let theta be cotangent inverse of 1/2. Whenever you have a positive input for all 6 inverse trig functions, this angle is always in the first quadrant. Okay, it's always in the first quadrant. And let's see. And the cotangent, so theta is a cotangent inverse 1/2, then cotangent theta is 1/2. This is a theta. Cotangent theta is adjacent over opposite. Adjacent is 1, opposite is 2. So the hypotenuse is square root of 5. Okay, hypotenuse is square root of 5. And remember, this is in the first quadrant, it's an acute angle. So they can write cosine theta is 1 over square root of 5. And then theta is cosine inverse of 1 over square root of 5. This is the steps for the problem C, so that you get this special transformation. So you just write back to the right triangle and determine the cosine inverse. Okay? And let's do one more. D. Cotangent inverse of -2. Cotangent inverse of -2. See, let theta be the cotangent inverse of -2. Then theta is in the second quadrant. Theta is in the second quadrant. Cosine is also positive, right? But yeah, and that's sorry. In the second quadrant, cosine is negative. But it's in the second quadrant. It's still in the range of cosine inverse. My bad. Cosine theta is it's negative, but it's still in the range. The range of a cosine inverse is between 0 and pi. Okay, so cotangent theta is -2. So we write a reference angle, we put 2 and 1. Cotangent, adjacent over hypotenuse. So by the same process, you will get hypotenuse equal to square root of 5. Then the cosine theta is what? Is 2 over square root of 5. Cosine theta is 2 over square root of 5. But it is in the second quadrant, so it's negative. The second quadrant, cosine is negative. So you get 2 over square root of 5 and with a negative sign. Okay, and also because it's in the range, so theta is a cosine inverse of a negative 2 over square root of 5. You see, that is the reason you see those special values, and the reason why you put a negative sign. It's just because it's in second quadrant. All right? Okay, let's make this type of stuff, this type of a computation abstract. This is a part 4. Write a trigonometric expression, as an algebraic expression. Okay, so how do we do that? For example, they want to study what is the sine of tangent inverse of u. Sine of tangent inverse of u. Okay, let's check. Let theta be tangent inverse of u. Okay, theta is tangent inverse of u. Then tangent theta is equal to u. And the theta is between negative half 2 and the positive half 2. And u is between negative infinity and the positive infinity. Okay? So what do we have? In this, we know that in this this is the fourth quadrant and the first quadrant. Fourth and the first. Only cosine is positive. Cosine secant is positive, right? Cosine and the secant are positive. And the reason we do that is the following. You see, tangent theta is u. Then we do the following. Let's see how do I get the idea. Assume this is theta, this is u, this is 1. I don't know u is a positive or negative. Okay, so here I just put the upper value of u. I have no idea about the sign. And then you will get the c squared is 1 squared plus upper value of u squared is 1 plus u squared, c squared. So c is the square root of 1 plus u squared. Okay, c is the square root of 1 plus u squared. So this is a positive number. It's not a problem. And then we can do what? We can compute sine. Sine, which value you choose? You choose positive or you choose negative? In the fourth quadrant, sine is negative. In the first quadrant, sine is positive because sine is opposite over hypotenuse. But you need a plus minus sign. This plus minus sign depends on the u. Then we have problem. I don't want this problem happen. I will consider cosine. Why? In the fourth quadrant, the first quadrant, cosine is always positive. So it's always positive. So it's a 1 over square root of 1 plus u squared. You don't worry about the sign. Okay, so I know what cosine theta is for sure. Okay, good. Now let's see what we can do. I'm looking for sine theta. Theta is tangent inverse. But I only know cosine. Actually, I also know tangent. You see, those two values we know for sure. Okay? Then how do we get a sine from tangent and cosine? So I'm going to do the following thing. We multiply top and bottom by cosine. Right? we multiply top and bottom by cosine. Then sine over cosine is tangent. Tangent theta is u. Cosine theta is 1 over square root of 1 plus u squared. So together you have this. So sine theta is equal to this. Okay, so this is a tricky problem. It's a tricky problem. And here I'm just trying to tell you why we don't start from sine directly, because for the sine with this domain theta, I don't know which sign you put, but I know that for cosine, I don't need to choose. The sign is always positive. So that's why we start from cosine. Once we get the cosine, we get the tangent, we use some relations, trigonometric relations to generate sine. Okay? Let's see another example. This is an interesting problem. Let's see more examples. Okay. So for example, we are looking for tangent of cosine inverse of u. Tangent of cosine inverse of u. Alright, then let's see. Let theta be cosine inverse of u, then cosine theta is equal to u, and theta, cosine inverse is between 0 and pi, and u is between -1 and +1. U is between -1 and +1. Okay? So, what do we have? It's the first and the second quadrant, quadrant 1 and the quadrant 2. Tangent positive in the quadrant 1, negative in the quadrant 2. We don't know the exact value so far because we don't know the precise location of theta. Cosine, what is cosine? Cosine, u is here. You write cosine theta equal to u, you can consider it like u over 1. So the hypotenuse is 1. Okay, so what is opposite? A squared plus u squared is equal to 1. So a squared is 1 minus u squared. So a is square root of 1 minus u squared. So a is square root of 1 minus u squared. So this is opposite. Then let's see. You want tangent? Oh, here you have to put opposite value because you don't know the sign of u, so you need to put opposite value. Tangent, again, like what I said, tangent theta negative on quadrant 2, positive on quadrant 1. I don't know the sign, but I do know that in the first and second quadrant, sine is positive. Sine is opposite over hypotenuse. This is always a positive trigonometric functions over first and second quadrant. So I do get this one, and I have this one. Sine theta is square root of 1 minus u squared. Cosine theta is u. What is tangent theta? What is a tangent theta? Tangent theta is a sine theta over cosine theta. Sine theta square root of 1 minus u squared. Cosine theta is u. So this is your answer. Okay? So you can see that in this type of stuff, maybe the direct question has plus or minus sign issue, but there definitely another trigonometric function so that you know the sign for sure. First, second, fourth, and first, and those choices. Once you know the sign for sure, you use that function, and together with the definition of inverse trig, you have two inverse functions, trig functions. You have two trig functions, you can generate the target. Okay, you can generate the target. Let's do one more, the last one. Yeah, we have time. Let's do one more. sine of cotangent of u. So let theta be cotangent inverse of u, then cotangent of theta is equal to u, and theta is between 0 and pi, excluding 0 and pi. Theta is between 0 and pi, and u is between negative infinity and positive infinity. Okay. The range of theta is 0 to pi. The domain of theta is negative infinity, positive infinity. And again, here is the first and the second quadrant. And that's good. First and second quadrant, the sign is always positive. So you don't have to worry about it. So let's check. When you have u, you write like u over 1. And u, we don't know the plus minus sign. It's adjacent over opposite. So you have to put opposite value. Adjacent over opposite. Then by the Pythagorean theorem, this is a 1 plus u squared. So the sine theta is, well, this problem is good. Everything is solved, right? Everything is solved. It's always positive, so you directly use 1 over square root of 1 plus u squared. You don't have to put a plus minus sign. It's a simple problem, right? Okay, so the fourth part, the part 4, the exercise is on page 621, problem 57 to problem 66. So you do those exercises and try to practice the strategies and make sure you understand all the steps. If you have a question, send me an email, okay? We finished this section 8.2. Okay, very good.